Hello, calculus students. I'm going to spend a little time talking about these antiderivatives today. This is a pretty important topic, and I think it warrants a short video. I hope it's short. I've got 4 pages of notes, which usually goes about 10 pages per 10 minutes per page. I don't want it to be 40 minutes long, but we'll see how it goes. Antiderivatives. So everything we've done before, we are now going to do in reverse. So let's get on with it. Let's get on with it. Full screen. So we're talking about these antiderivative things here, and let's just kind of write a little example here. First of all, we're starting with some function, and then we differentiate that. Right? We don't derive it; we differentiate it, and that takes us to the first derivative. Right, and that's what we've been doing for the past several weeks, is working with these derivatives. That takes us, from a function that we frequently call f of x, and that gets us down to what we traditionally call f prime of x, or df dx. Now, what if I knew that the first derivative, f prime of x, what if I knew that is actually x, 2x, right? Well, if I know that's the first derivative, the question becomes, what is, how do we get back up this way? What is that going to be? Well, let's see. I know from my basic rules that the power always kind of goes down by 1. So if it's to the first power here, it's probably squared up there. So it's x squared. Let's try that. So does that work? So if I take the derivative of x squared, sure, that gives me 2x. All right, so that's the antiderivative. All right, fine. Let's look at another notation of that. And now some of you may know that this is not entirely correct, but we'll get to that. A little alternative notation. I like to always consider all the alternative notation. Would be this. If I've got the function and then its first derivative, and we differentiate that way. Well, if my first derivative, if I'm giving an f of x, and I want to know what the function was that came before that, so I differentiated something that was up here to get down to here to f of x. We call that oftentimes capital F, big F of x. Now this changes from field to field, country to country, culture to culture, but most often we see it as a big F means it's the antiderivative. So this process here is the same as that I did in light blue. This is the antiderivative. Right. I don't know if antiderivative is necessarily hyphenated, but I'll put it in there. Well, the example we did before was this. The example was if f of x equals 2x, all right, easy enough, f of x equals 2x, so big F of x, the antiderivative, is, what came before this function. We said, well, x squared is a pretty good guess there. X squared, right? So that was pretty easy. Well, but we got to remain a little skeptical, so let's, or is it? Let's ask ourselves this question here. Well, so what, the way to do is to check. All right, so I claimed that if the big F of x was x squared, so that means that f prime of x, big F prime of x, which is my, which should give me back to the function I was given, equals, let's see, that's 2x. Right? Fine, no problem. I'm all good. But we need to consider all the options. What if I have a friend, let's say a friend who dresses frequently in green, and this person said, no, I got a different answer than you. I got f of x equals x squared minus 7. You know, come on, man, it's not x squared minus 7. But this guy checks his answer. He says f prime of x equals, let's see, derivative of x squared is 2x. Derivative of 7 is nothing. Oh, wait a minute. So this is, yeah. So my answer, x squared, give me 2x is my derivative, right? So that checked out. But then this other guy, the green guy, right, x squared minus 7. And that also gives me a 2x. Well, you know, you can see where this goes. Let's say the fuchsia person here, this guy, back in the 80s, fuchsia was pretty popular. The fuchsia guy says, well, it's f of x equals x squared plus pi. Right? He's kind of a nerd. He likes pi. And then you take the derivative of that. So f prime, big F prime of x, take the derivative. That gives me 2x. Sure enough, that is. So which one is right? The answer to that is, which one is correct? Well, we have to say it's big F of x equals x squared plus c. Whoops, that's not good. That erase. That any constant that we stick in there could make this work, right? So this key is called it's called an arbitrary constant. I wonder if I'll be able to get that. So I'll just quickly label this as the arbitrary constant. Right, and that's that thing right there is the arbitrary constant that we have to add on to any antiderivative, because any constant would go away. And so we have to include all the possible options by adding this little c onto the end there. So that's called the arbitrary constant that we have to add into any antiderivative. All right, so let's review the derivative basics, or differentiation basics. All right. We know that we have, first of all, the power rule. Let's check that out. Is the power rule. And what does that say? That if f of x equals x to the nth power, that f prime of x, what do we do here? Again, we discovered that once we do this expansion of the x plus h, blah, 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 that we always wind up with the exponent comes out front, and then the power goes down by 1, right? X to the n minus 1. Okay, that works. We also did a few trig derivatives. Let's review those quickly. If f of x equals, let's say, the sine of kx, where k is just some constant, right? F prime of x, well, we know that the derivative of sine is cosine, so it's the cosine of kx. But remember, we've got this blue box here, and we got to always keep in mind of the blue box, that here's our blue box, here's our blue box, but then out here we need the blue box prime. Right, and what's the derivative of the blue box in this case? Well, it's just k. Okay, so that's the chain rule, right? Let's label that as chain rule. From chain rule. Some of you may be saying, why am I making such a big deal out of the chain rule? The chain rule is huge, especially when we get later into what's called U substitution, integration by substitution. It's really, really important to understand the chain rule and keep track of nested functions. Here we have kx, which is a function inside of this cosine function. So the long and short of it is that when we take the derivative of sine of kx, we wind up with a k times the cosine of kx. All right. Similarly, if f of x equals the cosine of kx, f prime of x equals negative sine, pretty foretelling space I left there, of kx. And due to the same story, I got to put a k out front there. All right, so it becomes k times the sine of kx. All right. And one more that comes up, I'm not a fan of memorizing stuff, but there's one that comes up often enough, so I think we'll warrant it, is the f of x equals the tangent of kx, f prime of x equals the k times the secant squared kx. So the derivative of tangent is secant squared. That comes up all the time. Another really important one, C, is exponentials. And typically when we say exponentials, we mean f of x equals e to the kx, right? We can do it with other bases, but e comes up a lot in science and the natural world, so we'll stick with e. And business, finance, biology, social sciences, e shows up all the time. F prime of x, right? Remember, it just stays the same. That's what's nice about the exponential, e to the kx. Make sure that's an e. But chain rule says we've got to move the k out there. All right? And is there one more? Yeah, should we put logs in the same category? No, let's make it a separate category. We'll do D as logs. I mean, pretty close to exponentials. They're inverse functions of each other. And like we did above, we'll stick with a natural log. If f of x equals the natural log of, let's just call this x. Then we know that f prime of x will equal just 1 over x, like that. All right. So these are our basics. Okay. Well, now if we're going to try to do this in reverse, try these in reverse. All right. Well, what if I do this A? That looks like an @ sign. I didn't mean it to be @ sign. We're not tweeting. This is math. Hello. There we go. A. All right. If f of x equals x to the n, right? But now we want to take the antiderivative. Antiderivative. What is big F of x? Right, what's that going to be? Well, I remember that the power has to go up by 1. Right, so because when we differentiate, when we take the derivative, the power goes down by 1. But when we do the antiderivative, the power has to go up 1. Right. So my first guess at this will be pretty obvious. Right. What's it going to be? I'm going to guess that f of x equals x to the n plus 1. Sure, no problem. Right. Power's got to go up by 1. And then, well, we learned in that previous example that we got to add a c to everything, so to make our guess a little stronger. But we better check that. All right, let's check that thing. So big F prime of x, right, which we're hoping gets us right back down to our original function, will equal, let's see, how does that rule work? The power rule of the exponent comes out front. So I got to move that out like that, times x to the, well, that goes down by 1. If it was n plus 1, now it just drops right down to n. And then plus c, well, constant derivative goes away, right? The slope of a horizontal line is 0, so that just goes to 0. Ah, shoot. this didn't work out so hot for us, did it? Because I wanted to get back to my original function, x to the n, but I wound up with this n plus 1 x to the n. So that didn't quite work out. Let's neatly cross that out, right, which is what we do. So this, that didn't work. Right, I still want to be able to read it. So we learn from our mistakes, but that didn't work. So next guess. You didn't think you'd get all the way to calculus and still be doing guess and check, did you? So the second guess, I need to get rid of this n plus 1, so I'm going to put a preemptive little factor in there. I'm going to put 1 over n plus 1, and then x to the n plus 1 plus c. All right, now let's check this. So my f, big F prime of x, which should equal my f of x, equals, how does this work again? Okay, the power comes out front, so it's n plus 1. Yep, come back. Yeah, that's a little sloppy. I'm probably not going to edit all these little things out here, guys, just because it takes me so long. So it's the power comes out front, n plus 1, and then times 1 over n plus 1, the constant stays there, times x, and then the power goes down by 1, it goes from n plus 1 down to n, plus c, the constant horizontal line, slope is 0, that goes away. All right, now, yeah, I was waiting for this. Get out the all-powerful red pen of cancellation, those cancel out. And so this says that my f of x must have been x to the n. Right, so that worked out. So I made a guess at what the original function must have been, and I took the derivative of that, and sure enough, checks out. So pretty happy about that. Check mark, smiley face, whatever you like to do. And so this must be our right answer. Right, this guy here. Okay, and let's not lose our, that's our big F of x there. Okay. So yeah, that works. Now that's a little abstract. We didn't use any real numbers. I know it's confusing, but I want you guys to see how to do these very generally. So now how about trig? B, trig. I don't have much room there, so let's try that on your own. All right, and then let's over here we have a little more room, so we'll do some exponentials over here. All right. So we'll do it the same way. Let's start, say our f of x equals e to the kx. All right. Now these are the reason I like exponentials so much is because derivative stays the same. Derivative stays the same. That's what's so beautiful about that number e, is that the value of the function is the same as the slope of the function. So let's the derivative on my first guess is going to be big F of x. Well, just equals e to the kx, right? That stays the same. Plus c. Right? But of course we have to check. We're skeptical people in this class. We don't take anybody's word for anything. F prime of x, which we're hoping is going to be f of x, equals e to the kx. Yeah, chain rule. The chain rule comes into play here. So we got to look at this function here. We've got really nested functions. Kx is a function here, and so we need the blue box prime out there. Whoa, get out of there. I don't know what's, I'm hovering too close to the board or something. And so what goes in there is a k. right? Well, that's not what I wanted, because I wanted to just get e to the kx, not k e to the kx, so we got to get rid of that. That didn't work out for us very well, so this did not work out. So we need to make a second guess. Well, what's my second guess going to be? Well, I don't know what's going on with my tablet here today, guys. So my second guess. Well, let's. The problem with my first guess was this k, so I'm going to try to get rid of that k. So I'm going to guess that big F of x is 1 over k. So I'm hoping this k that the chain rule dishes out goes away. And so my check of that is that big F prime of x hopefully gives me... What is going on? This is horrible. I'm sorry, guys. Can I erase like this? So, you know, you're wondering, when do I drop F-bombs in these videos? So this is an example of where I would have dropped an F-bomb. But I'm getting older and I'm calming down a lot, so I don't get quite so worked up. So this is big F of x. Is my second guess. F prime of x equals, hopefully equals my little f of x. Equals, well, how does this work? E to the kx, right, stays the same, so it just remains 1 over k times e to the kx. But the chain rule says I have to put this k out front here. And let's make note again in blue that that is from the chain rule. And so what does that allow me to do? That allows me to cancel out my I think that allows me to cancel out my k's here. That k cancels with that k, that's good. And so we go back to black. And now this becomes, the k's cancel out, so it just becomes e to the kx, right? Which is what I started up way up here. So now I can check that off. That checks out. And so my, my second guess was pretty good. So you might see what comes up happening a lot here, and when you try to do some of these trig ones on your own, we wind up dividing by whatever constants were floating around in there, right? Or we wind up dividing by whatever the new power is, right, to make the constant go away. So that's roughly how those work. Let's do a couple actual examples with a couple actual numbers, just so you know, the practical amongst us can do a couple of these. Some examples. What if f of x equals x squared minus 2x plus 1. And again, I'm gonna just make a guess here. First guess will be big F of x. Well, I know the power's got to go down by 1, so let's call that, or the power goes up by 1. It goes down by 1 when I differentiate. Anti-differentiate, it's got to go up by 1, so we'll call that x cubed. Minus, well, we did this one before, that's going to be x squared, that's the first example we did, plus, now what about this constant? We haven't done one like that before. Let's see, so to get back down to a 1, this is really, you know what I'm going to think about this as? I'm going to think about this as a x to the 0, so the power's got to go up to x to the first. So that's just x, like that. And I remember I got a plus c. All right. And So when I check that, okay, I'm still in the right, so let's check. I want my f prime of x. Hopefully that looks like my f of x, which equals, let's see, x cubed, the power comes out front, so that's 3x squared minus, let's see, 2, the power comes out front, 2x, reduce the power by 1, so to the 1. The power goes down, this is x to the first, so that goes down to x to the 0, which is just, all that's left is a coefficient, plus 1, and that goes away. So how did I do? I want this to look, shoot. Got this 3 left here. So it all worked out pretty well, except for that first little section here didn't work out very well. So that, everything else worked fine. What did, oh, I forgot, yeah, you got to raise it to the power, but then divide by that new power. So let's try a second guess here. Big F of x equals, I got to raise the power, but then divide by the new power. So I'm going to put a 1/3 out here of x cubed. And then the rest of this stuff worked out okay. Minus x squared plus x plus c. And then when I check that one, that gives me f prime of x, which hopefully looks like my original f of x, which equals 3, power comes out front, times 1/3, times, that becomes, the power goes down by 1. What did I do here? I moved the 3 out front, reduce the power by 1, 3 times 1/3 times x squared, plus minus 2x, and then plus 1, and the constant goes away. So how does this work out for me? This is, you can see where this is going to go. My 3's are going to cancel out. That's nice. So I'm just left with x. Wow, my pen is way off the tablet and it's still picking up there. I've got to reduce the sensitivity on this thing, I think. X squared minus 2x let's see, plus, yeah, plus 1, yeah. Good. So that matches my original function, so that checks out, which means that my second guess, I didn't get it right on the first try, but that often happens. Right. So that's my correct answer. All right. One more example. Let's do a trig one, because I like trig, and we might as well throw in our second example. I'm going to say f of x equals 2/3. Oh man, now we got fractions all over the place. Secant squared of, let's say, x over 3. Now, first of all, this is going to be a hassle, this x over 3, so I'm going to rewrite this as 2/3 secant squared of 1/3 x. It's just a little easier for me to look at, because now it looks like a constant times x, so when I do the chain rule, that's going to be easier for me. Well, I recall that the derivative of tangent is secant squared. I remember the derivative of tangent is secant squared. So my guess is that f of x is going to equal, well, this is certainly going to be the tangent of whatever this is inside here, 1/3 x. So then I got to do a plus c, but I got to, there's this 1/3 in here, so I got to maybe put a 1/3 out here, something like that. Yeah, so that's 2/3 maybe there, something like that. All right, so we'll see how that goes. Yeah, let's check that. So f prime of x is going to be, well, let's see, well, it's secant squared. We know that much of it. Of 1/3 of x. And that's going to go away, so I can get rid of that. And then what happens here, this is going to be the 1/3 and the 2/3, so that gives me a 2/9. And then, but the chain rule says that I've got to put one more 1/3 out there. Oh man, no, that's not right. That's not right. All right, let's cross that out because something. We were close. I knew there's like a 1/3 or a 3 going on. Let's try it again. I'm going to say that big F of x equals, oh yeah, I got to divide by the constant that's in here. So since it's a 1/3, I got to divide by 1/3, which really means I multiply by 3. So it's 3 times 2/3 times the tangent of 1/3 x plus c. Right, which means my big F of x that I'm shooting for is really 3 times 2/3 is just 2 tangent of 1/3 x plus c. Now I'm going to check this, and so f prime of x, which I'm hoping is the same as f of x, is 2 times the secant squared. I did it again. Two times the secant squared of 1/3 x. I know that the constant goes away, but then the chain rule says I have to take this 1/3 out here. Let's make a note of that. That's from the chain rule. That's from the chain rule, okay. And so f prime of x, which I'm hoping is the same as my original function, equals 2 times 1/3, 2/3. Secant squared of 1/3 x. Does that check out? Way back here, my original function, 2/3 secant squared of 1/3 x, 2/3 secant squared. Sweet, it checks out. So I put a big old check mark by there, and that means this must have been my correct guess for what the antiderivative is. All right, so check, 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 a lot of guess and check. The only way to get good at these is to practice, practice, practice doing these, right? These tools need to be very readily available to us. That's it for antiderivatives. I lost my timer, 33 minutes long, so it's a little shorter than the 40, longer than I wanted it to be. But that's it, guys. Let's call that a recording. We'll see you in class.